Alright, what's up guys? So we're continuing on the MPI stuff. I'm going to cover the other function I didn't get to in last week's video, which was the send and receive functions. So if you haven't seen that one, I would suggest watching that one first. Link being posted up again. This one just kind of builds up upon it. I guess you can watch this one on its own, but this still does assume that you have MPI installed. So also do watch that one first if you don't have MPI installed. Also post it up. But let's go into it. The example code, the link is in the description. It's pretty much copy and pasted. We're just going to go through integrate, then I'm going to go through some of the functions they have in there, and we'll go from there. If you appreciate this series, if you appreciate the documentation I'm going into and all this work that I put into all these videos, please give this video a like and subscribe. It really helps out the channel, and let's go into this example. Okay, so now we're going through the subroutine integrate, which is the next example of the code, and the code is in the description if you want to just look at it, but I'm going to go through this line by line, just describe what's going on. Now in here we have a pi parameter that's just pi to some decimal point, and then we have some variables declared. We have a root process like before, which is set to 0. We do our MPI init to initialize everything, and our com size and our com rank. Now if you've noticed, you pretty much always call this first. It's always good to know what CPU you're working with, which is in this case my ID, and then how many processes you're working with, which is num process, whatever. Now, after you do those MPI calls, now we're going into what if statement we're working in. So depending on what process you're in, if we are in the root process, we are going into this if statement, which is going to collect the number of intervals we're doing. And it's a pretty simple if statement. It's just getting the output from the user input. It's going to read that, and then it's going to do this first call of MPI, which is called BCAST. If you remember before, we were working with MPI send, which was sending the information to each specific process, which was how many cells you're working with. But MPI BCAST is a similar idea, but rather it just sends it to every process. So we're doing a number of intervals. This is how many intervals is each CPU going to integrate over. It's going to send that number of intervals to each CPU, just send it out, and then it's going to continue on. So if you consider what's going on here, each process is going to get this BCAST going on, and then each process is going to continue going on with the rest of this code. So right now, all the processes started here. If we had 4, the one that's numbered 0 did this process. All the other ones skipped over this, and now they got over here. They got number of intervals from the one that actually got something, which was root process. And then now they're all doing these next couple steps. So these couple steps is doing similar to what a Riemann sums is. They're getting the rectangular width, which we're defining as pi, and the number of intervals that we're working with. And then they're doing a partial sum. They're going from this do statement, which is going from the my ID plus 1. So 0 is the 0th process. We're working with 1, 2, 3. And then in here, they're doing the actual integration part. So this is just some math that's going on here. It's not too important and not really specific to what we're doing in MPI, but it's just some integration going on. And the integration that they're performing here is sine from 0 to pi. So if you were to do that more precisely, that would actually come out to the number 2. Now after it does this partial sum, so each process is going to have their own partial sum, and it's going to do a printout. This is going to print out what the my ID is. So we're going to see which process specifically computes and how much that partial sum is that they got from their own computation. Now MPI reduce is another cool thing that is an overall function that works on all the processes. In this case, we're doing is we're feeding this MPI sum function. So first we're feeding a partial sum, which is the variable that we have. We want it to output on sum, which is this next variable. In this case, we're just working with one variable, so we're describing it as a scalar. It is an MPI double precision, so it's a double, it's a float. The function that we're having it perform on is an MPI sum, which we can see back here. It's feeding it to root process specifically, so that's going to be the one that carries it. And then this is MPI com world and I error from the initialization. So what MPI reduce is doing is it's going to get all these partial sums from all your processes. So if we had 4, we had 5, 6, 10, whatever, you're going to feed all those partial sums to this specific sum. You're going to sum them all up, output it on sum, but it's only going to give it to the root process. So once again, this is another check on who is the root process. And whoever is that is going to go into this print statement and print out the sum and then it's going to finalize and exit out. So all the other processes are done. Root process just does a final printout. So MPI reduce is another cool thing. There is specific functions that you can call within it, and across the documentation that I've linked up, they put more specific like other examples that you can perform on there. Sometimes you do logic statements, but it is another way to speed up things. Of course, you can also just design your own thing and just have each process work on whatever data it's working on. Okay, so we have all that. It's already compiled, but if I do a main, just run it. I was asking for the intervals. Now, if you remember, it should come out to 2. So I'm just doing 10 intervals. And it only has the one process, and it came out to about 2.001 essentially, which this isn't super accurate. That's because we only did 10 intervals. So if you imagine remon sum, we add 100 this time. You can see we got a couple more zeros this time. So it came out better. Okay, so now let's look at as an MPI run. We do 4, do main. Okay, so now I'm gonna do 1,000 this time. And you can see we still got our 2, right? So each one did the partial sum, each one did the partial sum and added them all together. But you can also see how much each one is computing, which because this function is fairly simple, each function got about 0.5. Then add it all together and we got 2.0. Now if I were to run this again, but just as main, do 1,000, and you can see it came out to almost the same precision. It gets off a little bit at the very end, which is probably just the flow precision that's going on, but still it was pretty close. Now, if you imagine that you're working with bigger data and you had to perform this heavy integral, maybe you're performing a triple integral or something crazy, break this along all the processes and do all the addition and just simplify it all down. So with MPI, I still have a couple more things that I want to cover. Probably happen later on in the month or so. I have some documentation I want to read up on and go into maybe how to link a GPU with CPU and do some of that stuff. That's a lot heavier in documentation, so that might be a bit farther off. MPI itself is super raw. There's tons of examples, tons of different functions and calls that I can go into. If you have specific ones that you want me to cover, feel free to comment in the sections below. Maybe you came across some code, maybe come across some examples that are pretty dense. You want me to go through it, people like it or whatever, then I'll go through it. Okay, and that's what I have for you this week. So please give this video a like and subscribe. Feel free to comment in the section below or tweet at me at djsofficehours or email me at djsofficehours@gmail.com. All that stuff is in the description. Hope you learned something new, and I'll see you guys next week.